You are listening to Missed Apex Podcast. We live F1.
G'day, and welcome to Missed Apex Podcast. I'm Uncle Steve, and again I'm here in the podcasting broom cupboard, finishing off the fiddly bits of this New Year's Day show. We hope you weathered all the revelry without too many hangovers and embarrassing moments, and that you're ready to kick off 2023 with some F1 fun and frivolity. But before we get funny and frivolous, let me remind you that we are an independent podcast produced in the podcasting shed/cupboard/cardboard box with the kind permission of our other halves. We may be wrong, but we're first. Today's show title is Forbidden F1 Fruit, and we're taking the Wayback Machine out for a spin to venture back through time and space to look at some of the technology breakthroughs that have revolutionised F1 through the years and then been banned for whatever reason. Later, Trumpets and Kyle talk to one of our own Missed Apex patrons, F1 engineer and former Cosworth engine specialist James Wingfield, about the heady days of hot and cold blown diffusers. But first, Spanner sat down with our resident F1 history buff, Jeff O'Boyle, to look at the early days of F1 ground effects and the amazing Brabham BT46 fan car in particular. I've got to say that this segment really excited me because this car, and the six-wheel Tyrrells that preceded it, were really responsible for getting me seriously into F1. It was the amazing technology and, of course, the insane speed that did it to me. So, let me twist the dials and pull the levers, and off we go, back to a time when F1 cars really sucked.
Hi everyone, Spanners here. I hope you had a good Christmas and have celebrated a new year that hasn't left you in too much of a muddy pool on the floor, rocking backwards and forwards, asking why you saw the new year in with such ferocity. But sit back and relax, because this segment is taking you back into the past. And I have someone who comes onto this show to tell me things, and it's Jeff O'Boyle. How's it going, Jeff?
Very well, Spanners. Happy New Year.
Happy New Year. You are a knower of things in the past of Formula One.
Well, I have access to Google just like anyone else. I do my best. I do find myself reminiscing and looking back to the 70s with rose-tinted glasses, and to ignore the fact that 1 in 3 drivers would generally be wiped out in some horrific fireball, and look at the happier times such as this one.
See, when you were saying that, I was like, yeah, races were boring back then, but then you made it a lot more macabre. And I'm lucky enough, I think I grew up in an era where a death or a serious injury in Formula One was very much a shock. So as someone born in 1980, my first real memory was Imola 94.
Yep.
And that kind of memory really kind of woke everyone up of my generation. But of course, if you're a lot older than me, like you are probably, Jeff, look, I'm only judging by your physical appearance.
Yeah, I mean, time has been cruel to me. I'll give you that.
Yeah.
But yeah, I do have to look back at the archives for a lot of this stuff as well. I'm not quite as old as my physical appearance or mental inability would suggest.
How often do you go back and watch an old race? I have to say, I've done it very rarely, and I've only gone back. I've looked at like some early 90s races, or maybe like, you know, the beginning of Damon Hill's career, and as interesting as it is to see those cars and how difficult they seem to be to drive, the races weren't as fun as they are now.
Yeah, the races weren't as fun. I'm not going to pretend that they were. Sometimes the field spread was just exceptional. Sometimes, you know, you can see there's a good reason why points were only awarded down to 6th place, because you were lucky if seven cars would finish. So yeah, sometimes they were a bit dull. What I'd like to do is with the F1 TV subscription, I'll go back and look at the season reviews or look at the highlights from races, and that's actually quite good, because you still get the beautiful slow-mos of Jackie Stewart power sliding through, you know, Tamburello or whatever, but you don't have to sit through 2 hours of watching someone win by 3.5 minutes.
No, and look, you didn't come here to just reminisce in general, but I do like looking back, and not just because, you know, we've got a lot of new listeners that are newer fans to Formula One, and to add some historical context, I always learn stuff every time you jump on. I think I know. Like, you know, you even when we did Webber versus Vettel, I go, I remember that. That was only recently. But you did give me like a really good refresher. And my absolute favourite thing is, as much as you You take us back in time. You give us all the historical context. My absolute favorite bit is people nitpicking in the YouTube comments. So please, if you have any minor corrections for Jeff, just stick it in the YouTube comments and make him feel terrible.
Yeah, thanks for that, Spanish. I really appreciate the encouragement you're giving to the trolls. That's kind.
No, You're not giving us like a, it's not like an exam where we have to pass an exam at the end. You're giving us a feel. You're taking us back in time.
Yeah, I mean, the era we're talking about today, sort of late 70s, I was 1 year old when a lot of this took place. So it's not exactly on the tip of my tongue. So we do have to look back and research, and I will occasionally get things wrong. It was part of the charm of Murray Walker for so many years. And he wasn't subjected to the same sort of online abuse, mainly because we didn't have the
there
internet.
Was no internet.
Yeah, so yeah, just bear that in mind. If it was good enough for Murray to make the odd shambles, then please afford me the same.
What's the Missed Apex motto? We might be wrong, but we're first. Today we're talking about the infamous fan car.
Yes, so I guess what triggered this sort of topic this year was the Goodwood Hill Climb this year. You might remember there was a car called the McMurtry Spearling that absolutely smashed the hill climb record this year by over 2 seconds. It went up in 39.08 seconds. And it was an incredible drive. Max Chilton, ex F1 driver, you probably remember who he was, was at the helm, and it was one of the most incredible pieces of motor racing footage from 2022. I'd implore you to, or I'd commend it to you to go and have a look at it. It really is exceptional. And there were two things that were remarkable about that car. The first one was it was electric. It's all electric. And being Irish, I still have a fairly mild suspicion of electricity. I don't think it'll ever catch on. I think there's nothing wrong with candles. But
they've harnessed the sun and put it on the ground.
Yeah, I mean I sound a bit like a flat earther in this respect, but I don't believe that electricity is real. It's a myth. It's a construct. But anyway, that aside, the second thing that was exceptional about the McMurtry Spearling was that it had a bloody massive fan stuck on the back of it. And the idea was that this fan would spin at high speed and suck air underneath the car, creating a vacuum and push the car down into the ground. So it's ground effect. It's creating probably as much downforce as a Formula One car at top speed. So it's an exceptional piece of kit. And that got me thinking about the original F1 fan car, which was the Brabham BT46B. Most listeners will probably have seen pictures of this car in the past. It's right up there in terms of its sort of infamy, like the Tyrrell P34 six-wheeler, or the March 701 with the surfboard nose on it, one of the most hideous cars ever to come out of Formula One. But there's an interesting backstory to the car itself, and it was short-lived but hugely successful, which we'll get into.
It's interesting, the concept of ground effect. Obviously, we're sort of meant to be going back to that now, so that's why the teams are trying to run nice and low to kind of make this seal underneath the car. So the general idea is, if you can have a lower pressure under the car than the air, then the car will try to fill that vacuum. So it's kind of slipstreaming into the ground. Now, that's a horrible description, but I like the fact that, that like a vacuum cleaner, they're actively pushing air out of the back to kind of create this suction. Does this mean they had to have a kind of a seal around the side to make it work?
Exactly that. So just going back 1 year, in 1977, Colin Chapman at Lotus came up with the idea of applying sort of aerodynamic aerospace engineering to F1 cars by having ground effect. So the Lotus in 1977, the Lotus 78 was the first Formula One car ever to try this. And you've got side skirts down the side of the car. They can be made of all sorts of things, and they brush the ground and create a seal so that when the air is pushed underneath the car, it doesn't escape sideways. It's forced out the back. And that creates this vacuum, this ground effect. And in 77, the Lotus wasn't massively successful. So when the Lotus 79, unhelpfully named 79 in 1978, came out in 1978, a lot of the teams were really surprised by the pace of it. It was an unbelievable car. They launched it at Monaco, I think, in 78. So it wasn't unusual back then to have a car launch halfway through the season. It wasn't the thing it is today, where it's launched in February, So, but it was just unbeatable. So the Brabham 46B, the fan car, was sort of born out of necessity more than anything else. The Brabham BT46 wasn't a brilliant car in itself, and the problem that Brabham had, the problem that Gordon Murray, the designer, had, is that the car itself ran an Alfa Romeo flat V12 engine. Pretty powerful. It was about
Yeah.
50 horsepower higher than the Ford DFE that most teams were using, including Lotus, but it was heavy and it was really bulky underneath the car. So when you think about this flat V12 underneath the underneath of the car, if you try and run ground effect through that car, there's no way it's going to be as effective as it would be on something like the Lotus, which was pretty much perfectly smooth under there. The engine, the bulkheads, or the cylinder heads rather, the exhaust mechanism all gets in the way of smooth airflow. So the Brabham didn't have the luxury of just doing a Force India and copying the Lotus 79. It wasn't an option.
Alleged.
Allegedly, of course. They were heavily inspired by the Mercedes. Yeah, so they had to come up with an entirely new idea. And the BT46 itself, before the fan car, was quite interesting because to get around this weight problem, Gordon Murray had the idea that they would run a car without any radiators. So it was the original zero side pod concept, like the Mercedes of today or the Williams. So they ran these things, like they were called heat exchangers, on top of the minimal side pods. And the idea was that would reduce a lot of weight, and so the car could be competitive. Unfortunately, the car just overheated and blew up.
I have to say, look, this is a struggle I've had in the engineering world, which is design engineers don't, for some reason, they've got a blind spot. These guys who've gone to like Loughborough University, mathematics wizards, can do CAD drawings you couldn't believe. They seem to have a blind spot for overheating and for the need for cooling. And when you're like just like a dumb ex-grunt who's sitting there saying to them, look, I'm telling you, I've used this stuff before, it's going to overheat. You need liquid cooling in here, ideally. And if not, you at least need some way to get the heat away. You need fans blowing the hot air away from the thing you're trying to make work. And for whatever reason, they will not do cooling unless they absolutely have to. And one of the great examples was, that Mercedes Beast, I think 2016 in Singapore, and they're literally hacking bits out of the bodywork because they suddenly realize, and I guarantee you there'll be some Derek in the design office seeing them hacking bits out of the bodywork who's like, I told you, I literally told you needed more cooling. So this is the ultimate version of it. Radiators, for people who don't know, they'll be circulating liquid which will carry heat away, and then the movement of the air as they drive along cools that air down. So you've got this engineer who's gone, well, they're heavy, we'll just do away with all of that, and unbelievably it overheated.
Yeah, I mean, who could have thought that could have been the end result of this? So the car was launched in 78 with conventional radiators. It was just too heavy to be competitive. But behind the scenes, Gordon Murray was working on this fan car, and I think he might have taken inspiration from there was a car in the Can-Am series in the US, a sports car series called the Chaparral 2J, and it was around 7 or 8 years before the fan car appeared, and it was a horrible looking thing. If you Google it, it's a big boxy. It's like an even worse version of a 1980s Volvo.
Yeah, you've sent me a picture of it, and it definitely looks like a student project. It is just a block of white metal, and you can't see any of the rear part of it because it's basically got this box over it, which I'm assuming is acting as kind of the ground effect skirt, and then you've got two massive fans pushing the air out. And this was like 10 years previous.
Yeah, it was. Yeah. I think it was around 1970 that was launched. It had one season and was banned at the end of the season. A lot of the other teams complained that it was kicking up dirt and rocks and things into their drivers' faces, and that's something we'll come back to in terms of the Brabham and one of the issues around it. But this car, this Chaparral, was just horrible. It's if you've seen the Simpsons episode where Homer gets to design his own car, the Homer, it's as ugly as that, and just a real horrible thing. But it did create a lot of downforce using two fans that were powered by their own motor at the rear of the car. Problem Brabham had is you can't just install a second engine to power a fan at the back of the car. The rules at the time stipulated that any fan that could be used for cooling had to be primarily for cooling. So, I mean, they were very clever. Brabham did design it so that over 50% of what the fan did was cool the engine. But the other 50% or 48% was downforce,
Okay,
creation of downforce.
so let's paint a picture for the audio listeners here. If you search Brabham fan car, I mean, you'll see pretty quickly what the concept was, and it was like a giant cone fan just stuck on the end where the monkey seat used to be. Oh, monkey seats have gone now, haven't they? That's how very early turbo hybrid era of me there. But underneath the rear wing, basically this huge cone with a giant fan. So I like the thinking that, you know, even though primarily what they were trying to do was push the air out to create this vacuum, they have to kind of, for the sake of it, make it help with cooling as well. But this car, if I'm piecing this together right, they launched that season. This is the one where you were saying they didn't have the radiators, were struggling with cooling anyway. So okay, so at least they had some cooling now. But they also had a giant fan. Can you imagine what the other teams were thinking when this giant fan turns up?
Yeah, they weren't impressed. There were 4 teams that protested the car before it even turned the wheel in Sweden. It was launched in Sweden in 1978. They protested it. The governing body inspected the car, deemed that it was legal, and therefore it raced, and it we'll come on to what it did in the race. But yeah, it was legal. But I guess if we look back at Mercedes and Red Bull over the last couple of years, something you constantly hear is it's not within the spirit of the regulations, which means that we wish we'd thought of that, but it is legal. It's not within the spirit if it's beating us. Flexible front wings, all that kind of stuff.
Yeah, so
sort of
there's a few examples we can point to. Probably the biggest one is the Frick hydraulic system that was able to, I can't remember how all that worked now, but it basically helped them keep the car level through corners. Mercedes car.
Yeah, absolutely. And actually, throwing back to Brabham in the 1970s, they also designed a pneumatic system within the car that would lower the car at high speed. So it did the same sort of thing, and other teams developed it. I think it was banned at the end of 1978 or 79. But yeah, I mean, this Brabham team were, you know, hugely underfunded compared to Ferrari, for example, but they were really innovative. They were the first team to use carbon brakes and discs. They were the first team to design a car using computer aided design, or CAD. The first team to use computers to analyze data over a weekend at a race. So they were pretty much ahead of their time, and they had some big hitters in the 70s and 80s. The team was owned by Bernie Ecclestone. They had Gordon Murray, as we've talked about. They had a list of luminaries who went on to great things. Charlie Whiting was there as well. So yeah, they were a really innovative team at the time. In the race itself in Sweden, in qualifying, the car was so fast that Bernie Ecclestone instructed Niki Lauda to slow the car down as much as possible. So the 2 drivers were instructed to fill it up with, the team filled it up with fuel, ran hard tires, and the drivers were told to lift off. So they didn't actually qualify in pole. Job was a good one, and Andretti got pole in the Lotus. Lauda was second, about 7/10 behind him. But in the race, I think Lauda said afterwards, it was embarrassingly easy how easy he won that race. He won by 34 seconds and was just coasting. Andretti's engine failed as 5 out of 6 would have done in that era. But in any event, there's no way he could have caught this car. It was just leap years ahead of its time. It's like the FW14B Williams, or the Red Bull that was absolutely dominant the first season, 2000. I want to say 2007. The car was just light years ahead. Possibly gone too early there with 2007.
You've gone too early. You've gone way too early. 2010.
2009, is it? 10?
Yeah, 2009 was right. Brawn with the diffuser.
Yeah, that terrible era, very boring era of Formula One. that whole era, you look back at the 70s. But yeah, so the car won easily, and the drivers had to drive counterintuitively. So the harder you push it, the faster it goes, the more grip it actually generates through the fan. So at a time when you should be lifting, going into a corner, you got to bury the throttle and push it into the ground.
So I'm interested. How was the fan governed? Like how was it the more you did the throttle, the harder the fan went?
Yeah, effectively, the harder it spun, and the more. I think I did four clutches within the fan mechanism itself. It's really complicated and made from tank parts. As a former military person, you might be interested in this.
No, tank regiment people are they're genuinely weird. And if you're listening, don't email me. I don't care. I've had several tank regiment people tell me that they think a tank is better than a fighter bomber. That's the level of person in, and they will not be budged on that.
If they can make a flying tank, I might be with them on that. But until that day, yeah, I'm with you on that. But yeah, it was an interesting piece of kit, very, very clever. And after the race, Mario Andretti claimed, I think probably egged on by his team boss Chapman, that when he was following the Brabham fan car, there was rocks and dirt and all sorts of stuff being thrown
it's a
dangerously at
safety
his
issue.
face.
Oh, yeah.
So safety issue. Again, the car was legal. There was nothing wrong with the car, but this is where we see the first hint of Bernie Ecclestone's big picture. So, 1978, Bernie Ecclestone was appointed president of FOCA, basically the team's constructors association.
Oh, okay.
Now, Bernie had big plans, and he was going to see them through. And being a dominant team owner might have thrown a bit of disharmony around his own position, or put some a conflict of interest in his box, if you like, his inbox. So Bernie withdrew the car after one race undefeated. It's still the only F1 car in history to be retired with a 100% success rate.
And without being forced to. So the team,
he could have run it.
The team owner, Bernie Ecclestone, voluntarily goes, "Oh no, that isn't in the spirit of the rules." Absolutely. That's so interesting. Had any other team come up with that, they might have. Like, where were Brabham in the championship at this point?
Yeah, they'd had a pretty mediocre start to the year. I think they were around 7th or something, because the car was just too heavy. It was too uncompetitive. But the fan car would have changed everything. And it's a shame in a sense that we never got to see how that design would have evolved, because Gordon Murray was already working on a new fan car for 1979 that apparently had multiple two different fans, different speeds depending on what you could do. And the thing about ground effect in the Lotus against the fan car in the Brabham is that ground effect works well on fast corners. You'll have seen that in 2022, that the cars are planted through fast corners, but really tricky through some slow corners. They're through hairpins and things. They're a bit meh. That's because obviously the car's not going fast enough to generate enough downforce to push it into the ground in slow corners. The difference of the fan car is that you could keep it planted. It didn't matter. So the downforce wasn't being generated by speed. It was being generated by an external force at the rear of the car. So it was in phenomenally fast through fast corners.
So from a driving style point of view, even in a slow corner, you would want to get the speed off as quickly as possible, so nice and early, probably in a straight line, point it towards the corner, get those revs up, get the fan going, and then you're basically on train tracks. And I think there was a similar comments from Sebastian Vettel when he had the double diffuser, so that was generating extra downforce at the rear, and he was accelerating at points where other drivers were still braking into a corner. So it's fundamentally had to adapt his driving style to the way this car was able to drive. So for those guys, it must have just been, like a local go-kart track, like an indoor track. Hit the corner, get the speed down, point it into the apex, and just pin it like from way before the apex.
Just bury it. Exactly the same. And the active suspension in the Williams, the FW14B that we mentioned earlier, same issue there. That once Mansell had confidence in that, he was unstoppable, because the car, it's counterintuitive to plant it before the apex of the corner, but it just worked. It just sticks to the ground. And the fan car was the same. So instead of seeing aerodynamics develop through 1979, early 1980s, and ground effect kind of become a thing and then become banned, and then wings become more important, if that car hadn't been withdrawn, who knows what direction F1 could have taken itself. The McMurtry Spearling, going back to what we talked about at the start, smashing the Goodwood record by 2 seconds over an F1 car, shows that a fan is still a really effective way to generate downforce. So could we have seen 20 cars with multiple fans on the rear, one huge fan? It would have been fascinating to see where the technology could have taken us.
And we'd never have had really that long era where you couldn't overtake because of the aerodynamics and the dirty air being generated. It could have been a completely different formula. And I've been whinging for the last 6-7 years here on Missed Apex about why is aerodynamics the most fundamental thing? And I've often wondered why, given that everybody goes, well, the aerodynamics are ruining the following, they're making the cars too planted, and they're basically straightening out every corner in Formula One. That's how good they've gotten. But I don't think you can get rid of it because there is such an ingrained mentality of aerodynamics. If you suddenly went no front wings, no rear wings, you'd have thousands of unemployed people in Formula One. Like, spiritually now, you can't do that. And would it have been more interesting in F1 if it had gone down this ground effect route? Or now, as we go into the electric era, presumably we can have a motor on each wheel fairly soon. They're going to have some kind of motor on each wheel, and you can derive grip and direction change from there. And this is the long battle with F1 tech, isn't it? As soon as someone has an innovation like that, the authorities have two choices: A, let it ride, and everybody then will copy that. So effectively, any innovation that you let ride, you're going, okay, that's now the direction of the sport, or you ban it. So obviously they looked at the giant fan on the back and went, nope.
Yeah, we're not having that.
No.
It's an interesting point you make about aerodynamics and how that became so important over the last couple of decades in F1. And I think that the issue is that the teams write the rules, don't they? So the teams employ, as you say, hundreds of aerodynamicists, and they want to keep them employed. And it's their hobby horse, isn't it? They want to see what's possible. And just because it's possible to create a car that's very grippy through aerodynamics doesn't necessarily mean that we should do it.
I know.
There would be much more interesting ways. I think mechanical grip and big fat tires and 1,000 horsepower engines will always have much more romanticism for me than something that's generating a huge amount of downforce through wings and you can't get within 5 seconds of it.
And it's invisible. You can't see it. You can't really hear it. You just kind of, like I feel for the tech journalists, Matthew Summerfield and Scarbs and stuff, and they're trying to do these beautiful drawings, and it looks like ancient Greek, to us. Whereas I think we could get our head around more the fan car type innovations. Horsepower is a more they generated more horsepower. Oh, that's a bigger number than that. Whereas aerodynamics is kind of a big mystery.
Yeah, it is. I wouldn't even pretend to understand how it works. In the rain, I kind of try and convince myself that I can see what's going on through the vortexes that I'm looking at, or vortices that I'm looking at. But the truth is, it might as well be in Greek, as you say. But the ground effect, I think, was banned at the end of 1979, and the key reason, I think, was that it was deemed to be too dangerous. If one of the skirts failed, the driver would appear, plant his foot, have no idea, and have a huge accident.
It works until it suddenly doesn't.
It's exactly that. But in the Brabham fan car, there was quite a clever little innovation that Gordon Murray put on the car, where he had a gauge inside the car that was either, the needle was either red or green, and it was an altimeter that was installed in the car. So if the gauge was in green, the driver would know to keep it planted, and if it was in red, he'd know that one of the skirts had failed in the car, and there wouldn't be enough downforce to get him around the corner when he arrived there. So
wow,
it was a sort of early innovation again, and trying to keep the drivers safe, but ultimately to no avail.
Yeah, the chase for ever more downforce and ever more lap time. The one regulation change that still makes me so angry is the 2017 one, because I feel like this was an internet derived change. And if you remember, they just had the turbo hybrid era, and actually the racing wasn't too bad, except that we had the dominance of Mercedes, and the unreliability was a bit of a hark back to the past. Cars were sort of conking out left, right and centre, especially the Renaults. But they had slowed the cars down significantly. The cars were heavier, and the internet, and I'm probably going to blame specifically Reddit for no reason at all, just massively kicked off. These cars are slow. It's pathetic. They're no quicker than GP2, I think it was at the time. Like, it was starting to get close, and there was just an outcry. And they changed the regulations in 2017. Okay, no, we'll make these the fastest Formula One cars ever, and it was rubbish. It was just like, why do you need the stop clock? Why is that so important as a viewer? But it was a knee-jerk reaction change for the worse. Curse you, internet.
Yeah, no, I absolutely agree. That making them, they're going to be 3 seconds a lap faster next year. I don't care. I want to see close racing. I want to see the field bunched up. I want to see cars moving around a bit. I want to see the drivers at work. I don't care that an aerodynamicist can build a car that can drive upside down on the ceiling. That's not what we're racing. I want to see cars going, at it through Eau Rouge, Radeon. I want to see excitement. I don't want to see a stopwatch and go, oh yes, it's 2.5 seconds faster than it was. I don't care about any of that. It's the same with, you look back at the 2007, 2008 cars. They were so much smaller than we've got today. We've basically got huge sports cars, WEC, LMP one type cars, just with no lid on them. And you see them side by side. Do you remember Alonso did the demonstration at, was it Abu Dhabi? It wasn't Abu Dhabi. Was it oh gosh, where was it? The R25, the 2005 Renault.
Renault, yes, I do.
Yeah,
and that was a bit of a PR mistake because everyone looked at that and went, "Ooh,
can we not have that again?"
Look at that. Listen to that. Was it the V10 as well?
Yes,
V10
it was
engine,
V10. Yeah. Right in if it wasn't, please. But yeah, no, it was beautiful. It changed direction so quickly, and it just looked the absolute bee's knees. And then you look at what we've got today, and there's a bit of variety between the cars, and it's more interesting to look at now than it was last season, for example. But are the cars really more exciting to watch on TV in particular?
Oh,
No.
yeah, maybe not on TV, but also it has to be the right track nowadays. So they do look great around, say, the Tilkodromes, basically, which used to get slated all the time, but now they seem to be the ones. Like if we could have Malaysia and Shanghai and the Indian Grand Prix and the Korean Grand Prix, all of those tracks would really suit these modern cars now. But that we've gone back. We've had Portimao and Imola coming back. We've gone in the wrong direction for these cars. But I would say go back and watch some of the 2007, 2008 seasons and watch Alonso and Hamilton going at it, and Raikkonen in the mix there as well. Particularly, let's say 2008 Spa. That was quite a good one to go back and watch Hamilton versus Raikkonen. Those cars were dancing around each other, and the tracks look massive. It's like when you go back to primary school and the size of the chairs is so different. You look back and you go, the cars are teeny. They're like micro machines.
Yeah, that 2007 series was brilliant. Sorry, season was brilliant. 2008 was brilliant. 2012 was also a good season. But if you get a chance to go to a motor museum, for example, and that is a good one at Monaco. If you're not knocking around in Monaco with an afternoon to spend. Look, you're in the continent now.
I nearly drove through Monaco out of curiosity, but because I always whinge about Monaco as a Grand Prix track, I was like, I can't then go. But from a history point of view, you go, oh yeah, remember Monaco when it used to be relevant and entertaining in Formula One? But I didn't want to be seen to be endorsing modern races at Monaco. Specifically, that's the reason we didn't go through it.
What, just a point of principle, you've literally cut your nose off to spite your face there.
Yes, but I have my principles unless you have money, in which case I'll abandon them quickly.
Quite right. It's like the old adage, there's two good reasons to marry. It's when you see the new cars compared to the old cars almost side by side, it's breathtaking to look at them, and I think it's just such a shame. I mean, I know I'm harking back to an era in the 70s when the cars were pretty big, but the tires were 25 feet wide. It was a different thing. And I was reading something the other day about the turbo era engines when they were first introduced, and there was one team that had 600 engines in a season, which they weren't always reliable, but I didn't think they were that unreliable.
Wow.
It could have been a typo. I hope it was a typo, but it definitely said
even
60
would be a lot. But look, before we turn into old men shouting at the clouds, because I didn't realize it was going to become old F1 versus new F1. There's a lot of plus points now, which is obviously safety for the one part. I do like that. There is close racing. If you look at the field spread, it is a lot lower. Reliability is better, so you're not robbed of just suddenly having 6 cars on track an hour into the Grand Prix, which has literally happened. There's less rubbish gravel, so you don't just get people make a slight mistake and be beached forever. You're going to email me about that, feedback@missedapex.net. But this has been really insightful, and make sure you go and Google. The 2 things people need to go and search up are the Brabham BT46B or just the 1978 Brabham fan car will get you there. That horrible boxy thing, what was that? That was the
Chaparral 2J.
Chaparral 2J. That's well worth looking at. And in general, go and follow Jeff O'Boyle on Twitter. Have you snagged the Jeff O'Boyle handle?
Yeah, I'm still Elon Musk has still mercilessly locked me out of my original account because I've forgot the password. But yeah, I think it's jeffoboyle1 at twitter.org.
We'll put a link in the show notes below, and make sure in the YouTube comments, just hunt the mistake and just pick up any little tiny errors Jeff might have made. Jeff, thanks for playing podcasting with us. I always enjoy a bit of a look back in the past, even if it does inevitably turn into two old men ranting and yelling at clouds.
Thank you very much for having me, Spanners. Really appreciate it.
Thanks, Spanners. Thanks, Jeff. The thing I found most interesting with that discussion was the fact that the Brabham team owner, one Bernard Charles Eccleston, kibossed the BT46B even though it was ruled to be legal, just to keep the other teams on side while he effectively took over the sport. Who said winning was everything? Anyway, it's now time to turn our attention to things that go huff and puff. James Wingfield is a committed Missed Apex patron, a serious caterer, racer and winner, and a competitive sim racer. He's also an F1 engineer, and in a previous life he was a Cosworth engine specialist directly involved in developing that company's blown diffuser strategies. Matt Trumpets and Kyle Power caught up with him and gave him the third degree about what he and his team did, how they did it, and just why the FIA decided to kill it off.
We are once again going to discuss exhaust-blown diffusers, and once again joining me today is none other than Kyle Power, who in addition to being a driver analyst is also a proper mad scientist type engineer, harnessing the fundamental powers of the universe for what I assume is probably not evil. Welcome back, Kyle.
Yeah, so very good to be back doing this and looking forward to continuing our conversation from the first show.
And we should probably explain at this point, the reason we are revisiting this topic is a lurking expert, super awesome special guest, James Wingfield, reached out. And in addition to being very quick and a caterer and not too bad in iRacing, I have to say, he actually worked on these strategies at Cosworth when they were being used in Formula One. So before we bring him in, why don't you real quick tell us what exactly we were talking about? Because as we all know, my memory is less than perfect.
So yes, for those of you who weren't listening to the first segment, which there will be a link in the description below, you should go and check that out, that we were exploring some of the banned technologies in Formula One, and we started off with one of our favorite ones, which is exhaust blown diffusers. And now the F1 teams were utilizing this which was wasted energy coming out the back of the exhausts, and they were blowing it into the diffuser to create copious amounts of downforce, and they were applying all sorts of crazy wizardry and tricks with engine mapping, cylinder cutting, hot and cold blowing, which we discuss in quite a lot of detail in the previous segment. So if you haven't listened to that, go back and have a listen. But someone who was listening to that and was probably getting angry and shouting at the screen was our very special guest, James. So, James, how wrong were we in that last show?
Yeah, hi guys. First of all, it's great to be here. I'm a big fan of the show, listened for quite a long time. So to get my moment on the show is great.
One of the things that drew us to this topic was the crazy sound generated with the off-throttle hot blowing, what the teams were doing. And I may have erroneously thought that the sound was to do with them igniting fuel in the exhaust, which is creating this crazy sound, but that might not be the case.
Yeah, I think there's probably a little bit more behind that. So, I mean, ultimately, obviously, the sound is coming from the explosions that are happening inside the engine. But the real variation in note, I think, had a lot more to do with the timing of those explosions and the effective firing order that the engines were running, as much as just burning the fuel in the tailpipes.
Okay, so I'm going to immediately ask you to explain that a little bit more for me, not being as much of an expert as Kyle. How can you change the order that the cylinders fire in? Because aren't they all connected and have to run in the same order?
We had V8s at the time, obviously in Formula One, 2.4 litre V8s. Now there's a definite mechanical link through the crankshaft and the arrangement of those 8 cylinders, which enforces the firing order to be whatever each of the engine manufacturers decided it to be. But that only really applies when you're in 8-cylinder mode. And there was one element of the mapping that was open to us all at the time, and I think probably still is to this day, but you can drop cylinders, so you don't have to fire all 8 cylinders all of the time. And that was really where and it's not a loophole because it was being used already for torque control, but that was really where the kind of expansion for hot blowing and the kind of opportunity to really develop hot blowing came from.
You mentioned torque control, and I presume that sort of links to what we hear sort of engineers say on the radio, all sorts of torque demand. So I presume that's when the driver's got a certain throttle position on, say they got 20% throttle, but they don't necessarily want 20% power. So you'd cut some cylinders to deliver the power that they want at that time.
Kind of. So the driver is obviously controlling the car, and as part of that, he's controlling the engine. Now he has a limited scope of information he can provide to the engine, which pretty much is just through his right foot. So as he puts his foot down, the more throttle pedal he applies, the more torque he is after from the engine. But what we do have in Formula One, or had then, and obviously even in road cars these days, is electronic throttles. We've moved on somewhat from the old days of a cable between the driver's foot and the throttle mechanism or blade or barrel or whatever the throttle valve was, where it used to be entirely tied to the pedal position. And now as the driver puts his foot down, that then sends a torque demand to the engine, which is slightly different to a throttle position. So then the engine and the ECU and the control unit can determine how to deliver that torque demand. There are some rules, and the FIA, particularly around this hot blowing period, were very interested in how the PU or the engine manufacturers were using both throttle position and generally torque control, because they were, I don't know if they were trying to clamp down particularly on hot blowing, but it was there was a lot of movement around that at the time, and everybody was very interested in how the throttles were being used. And it was something that was changing rapidly, race by race even. There were sort of slightly different control strategies at play.
I'm going to, first of all, have a laugh because I swear I recognized exact words from the FIA rule book when you were talking about the driver being in full control of the car. It's like they beat that into you whenever you were going to talk about something to the press. But I want to understand here, because my memory of the rule is that there has to be a linear relationship between the throttle position and the torque being delivered to the wheels. And you're saying that wasn't the case then, or that there was just some allowable play in what you could do based on the situation, the mapping you said that you were using for that particular track?
It doesn't have to be linear. And I think even, what is it, probably more than 10 years ago now, but I think the phrase that the FIA used was monotonically increasing. Effectively, for 1% throttle pedal, you'd have a certain amount of engine torque. For 2%, it had to be more torque, but it didn't have to be twice as much torque. So as the driver was putting his foot down, the engine torque had to be continually increasing. And that wasn't really so much around hot blowing or anything like that. It was more around torque. It wasn't so much around hot blowing. It was more around traction control, because there potentially would be a loophole where if the driver had his foot anywhere between kind of 0 and 50% throttle, you could play games with the delivery of the engine. Then in theory, I suppose you could have an element of launch control or torque or traction control creeping in.
So that brings us on quite nicely to our original subject of, we were just talking about drivers being on the throttle. So with the exhaust blowing, we're talking about drivers being off the throttle and on the way into the corner. So the whole point, and just a mini recap, is you want to keep gas flowing through the exhaust whilst the driver has got no torque demand or throttle on at all. So you're saying that you cut cylinders to help you guys achieve that? I mean, how did you originally sort of go about achieving that when you had to first start setting this up?
Partly that's an easy one to answer because it was already in place. Cutting cylinders wasn't new for blowing. It was already in place. And even having the throttles slightly open when the driver had zero pedal position is nothing new. That was already happening and has always happened in Formula One, really. So there's a little element of it being just a development of what was already happening. And it predominantly came from the teams saying, look, we would like to use the exhaust flow. I think you previously talked a little bit about the kind of the curtain of that exhaust flow being useful to prevent the tire squirt getting into the diffuser. And I think that was certainly the application back in 2011. That was very much the application that was being used. A bit like when you walk past a shop and they've got the hot air blowing down just in front of the doorway, it creates a bit of a seal between the cold air outside and the warmer air inside the shop. So that jet of air was very useful to them, and that was really how it started to develop. And of course, it started with cold blowing, later moving into hot blowing.
I want to hear about the evolution of why you went from cold to hot. But before we do, the question I got to ask is, did you find that using different combinations of cylinders make any realistic difference in the amount of downforce or the amount of seal that you were getting with either the cold or the hot blowing? In other words, did you say, well, we're already cutting cylinders 2, 4, and 6. What if we did 2, 3, and 7? Do we get a better result? Did it come about like that? Or was it just sort of what you already had going on that made for these different sounds?
Yeah, that's a really interesting one. So the cutting of cylinders, it was already in place because fundamentally these engines are designed to produce a lot of horsepower, near enough. Let's call it 800 horsepower at the time. It was about there or thereabouts. So if you've got 100 horsepower per cylinder and the engines are fully tuned to deliver that high airflow rate, that high fuel flow rate, what you tend to find is that when you ask each cylinder to deliver only a couple of horsepower at really low torque demands, as we're now calling it, they become very inconsistent. And sometimes the driver might ask for 3% torque or maybe 3% pedal and a very small amount of torque, but the engine can over or under deliver because each injector is flowing such a small amount of fuel that it's hard to meter accurately. The throttles themselves might have a little bit of air leakage through them. So what you find is it's actually far more consistent to have fewer cylinders working a bit harder than all of the cylinders trying to work really, really gently. And that's really where it came from. So the idea of dropping, let's say, from 8 cylinders to 4 cylinders was already in place. And it then depended on which 4 cylinders that you're firing to get the most out of particularly hot blowing. Obviously, with cold blowing, none of the cylinders are firing because the torque demand is so low that all of the injection is turned off, at which point you can open the throttle fully and the engine is now a nice big air pump, which I think is something that you covered already in the previous show. And you can flow more air through an engine with the throttles wide open than you can with them closed, but it's flowing through all 8 cylinders. So there's no real effect of different cylinders being fired in cold blowing. That only comes into play for hot blowing.
So for the hot blowing, so in all of this, I presume the main goal was to achieve maximum gas flow rate out of the back of that exhaust. So you just wanted to get the most amount of gas at a higher energy potential as possible through the exhaust. So why would you cut cylinders to achieve that? Surely you just want full bananas. Just let's use all 8 cylinders, throttles wide open, cut the ignition, force loads of fuel through, and basically have huge explosions in the exhaust to create loads of gas. Like, why wasn't that the case?
Yeah, well, that's another good point, and it kind of is the case. So the trouble is that you end up with loads of torque being applied. So as the driver's asking for less torque, if you're fully firing all 8 cylinders, you've got 800 horsepower coming through the rear wheels, and the driver's going into a corner trying to slow the car down. There's an element that you can tune it out with the brakes if the rear brakes are really meaty and can deal with that, but they tend to overheat very quickly. And you'll sometimes hear the drivers complaining of push, and that's effectively what that is. That's when the engine is delivering a bit more torque than they would like it to in that engine braking zone or the corner entry zone. And they'll say that the engine is pushing a bit because it's actually delivering a bit too much torque. It's great for the diffuser, in this instance anyway, when we go back to the kind of blown diffuser era, but not so useful for the fundamentals of racing a car around a track.
That's super interesting. So you'd cut half the cylinders, you'd force some fuel through because the cold blowing started, and as you said, cold blowing is pretty much turning the engine into an air pump, just pumping air through, whereas hot blowing, you'd manage to force some fuel through the cylinders, through the engine, and then that ignites on the hot exhaust, obviously creating more gas flow. You can only do that to a certain extent. And I presume also as well, fuel consumption goes through the roof at a certain point if you're pushing too much fuel through the engine. So why and how was the transition over to sort of hot blowing? Was this something that you guys knew was already sort of possible, or were you sort of reacting to what other teams were doing? So I think the general consensus is amongst us just normal fans who are not on the inside was this is sort of a kind of a Renault Red Bull sort of developed thing, or was this something that you guys were fully aware and playing around with anyway at Cosworth?
Yeah, the engine manufacturers all brought it to the table at different times, and honestly, I would probably say that we were a bit late to the party in that one with Cosworth. Cold blowing is something that we were aware of and doing. Hot blowing, we were kind of aware of it, and I remember, I think it was the 2011 track test, where the first on-track running was done with hot blowing for some of the other teams, and immediately, obviously, our trackside guys came back saying, hang on a minute, this sounds weird, much as you were talking about and the general public were talking about. So yeah, at that point we worked out that there was another element of this blowing game, and it was time for us to kind of investigate that and deliver something equivalent.
So that's fascinating. So it's a nice day. You're sitting at lunch, having your lunch, and somebody runs in and was like, right, we need to start doing this and looking into this. So how did it come about for you guys? Where do you start? You have an engine. You've basically been told, right, we need to start forcing fuel through this and igniting in the exhaust. Did you have to make any sort of architectural, actual physical changes to the engine, or is this all just sort of software and sort of mapping based?
A bit of both, I suppose. Now, the big problem here is we were operating under an engine freeze back then. So 2011, 2012 is when this was really happening. So the engine was technically tied down, but that doesn't mean that every single component was running to its limit all of the time. So there was an element of, we know that we can do something here to improve the air exit velocity. So let's try it on the dyno, see what it does, and then keep an eye on how different components start surviving or maybe not in some cases, and work out what the weak links are. And if you can cover those up with a calibration change, great. If you need a mechanical change, then that's where it gets a bit tricky, because if you ask the FIA to introduce a new exhaust valve, maybe because it's getting too hot, then they will consider that and then say, really, do you need to do this because you've actually got a failure, or are you pushing the limits perhaps? And worse than that, they even then send that request around to all of the other engine manufacturers to say, by the way, Cosworth have just asked for a new exhaust valve. So you have to be very genuine in what is actually a failure and what's perhaps self-imposed or self-created. So in terms of the hardware, there were definitely limits. And so we went out really with a calibration change. And at the time, calibrations were pretty well unlocked. They've become more and more tied down, I think, over this period, which is something that the FIA were getting hotter and hotter on, excuse the pun, as this blowing period became more kind of sensitive, I suppose.
So if you wouldn't mind just telling me what exactly you mean by calibrations, because there's maps and modes in this. So when you're talking about calibrations, what specifically are you referring to?
So the entire way the engine is run. If we go back to what I said earlier with the torque demand, so the driver says, I want a bit of torque from the engine. I've put my foot at a certain point on the throttle. It's really then the ECU that decides how to deliver that torque. Now, it might be that you give 100% actual throttle position, but you change your ignition angle and you create a later burn period in the cylinder. Or it could be that you change the number of cylinders that are firing. You can do all these kind of things within the calibration. So obviously when you're on the straight, you're full throttle, you pretty much just ask the engine to give it everything. But when you're in this entry phase into a corner and the driver's only at a little bit of throttle position or maybe zero, then you have different opportunities to increase the exhaust flow rate and reduce the torque delivery, which was the big game at the time.
And just a quick follow-up, is this calibration a lengthy, complicated, and difficult thing that you wanted to do as little as possible? Or is this because what I'm understanding is you could sort of tailor the torque demand to the driver and also potentially the track? Or is this something that you might have to do on a weekly or I guess back then a bi-weekly basis, because we didn't have races every week? Or is this just something that was done generally at the beginning of the season and mostly left alone?
It wouldn't really be tailored to the driver. It would be, so Cosworth, I think we had 8 power units running at every race in 4 different teams, and they would all be running pretty much the same calibration. There may be very small differences because you know that the Williams car has a slightly higher inlet temperature or lower inlet temperature or something. So there may be a little bit of team to team, but pretty much they're all the same. And in terms of how frequently they're changed, you can change them very frequently, but it's up to us to ensure that we're delivering a reliable power unit. So you don't want to be playing games and trying things at the track. So anything you're trying is done in the factory beforehand, and you need to run it on for a lengthy period of time to make sure that you are confident it's reliable before you send it to the track and let it loose in front of millions of people watching on TV.
So that's interesting you say about the calibration. So in theory, you could almost sort of frig certain parameters that so you don't want to be 100%, it's calibrated to sort of 60. This, if I'm Mr. FIA, this sounds like an absolute headache and a nightmare to try to police some of it, because as you say, you could maybe try to, it's kind of wading into sort of traction control sort of areas it sort of could be. But I've got a bit of a question there. So if it's dictated, these calibrations and sort of the parameters and basic operating parameters of the engine, you said you were supplying several different teams. So would this come from the team? Would Williams say, we want our engine to operate in this sort of window? Or I believe were you supplying Caterham at the time? The Tony Fernando, were they Caterham or Lotus? I can't remember at the time. Because when I stood by the side of the track in 2011 at Silverstone, that was the round where they tried to, on the behest of Ferrari, they tried to stop people hot blowing because Ferrari couldn't do it and spat the dummy basically. So the FIA had tried to stop them for that one round. But me standing by the side of the track, all the cars, you could kind of hear it going on a little bit, apart from one car where it was so loud and so obvious. And that was the Caterhams, which I thought were running a Cosworth at the time. And they sounded totally different from all other cars. So would they, for instance, come to you and be like, we still want to kind of do this, or we want to run the engine totally differently? And would you accept those requests?
It was a little bit more driven the other way in many ways. So I think the idea of blowing and improving the effectiveness of that blowing from cold to hot, etc., was a request from the team, because it was a team performance improvement. It didn't make the engine faster, but it made the car faster. So that initially came from the team. But once we started developing it, if you then start expelling air that's hundreds of degrees straight into the sides of the diffuser, it's then on the teams to make sure that the parts can survive. So the carbon diffusers initially were really struggling, and they ended up with metallic inserts and heat shields and things like that. So it's also back on the team a little bit of, if we as Cosworth say you can have this, it may be that they can't actually utilize it. And I honestly don't remember back then any of the teams using it and not using it specifically. But it would have been available to all of them if they wanted it. I think it was probably 2012 that we were more into the hot blowing rather than 2011. And at that point, Caterham wasn't the Cosworth supplier. Cosworth wasn't a supplier to Caterham. So that may have been a Renault engine that you were listening to then. But definitely the Marussia was running hot blowing with us in that year.
That's interesting. Yeah. So 2011, it was mainly Red Bull and McLaren, and in the first clip of the first show that we did about this, we included a clip from YouTube and you could hear the difference between the McLaren running the Mercedes engine and the Red Bull running the Renault engine. It was very, very different. So the Caterham, yes, probably was running the Renault at the time. So the FIA then moved the exhaust positions for 2012 and to take advantage of the Coanda effect. And this is probably more where the hot blowing comes in. So this is where sort of Cosworth, you guys sort of ramped up your involvement then, which is really interesting. So was that much of a challenge? So this rule set change between 2011 and 2012. You went more to sort of hot blowing over the season. There is an engine freeze, and we've kind of touched on this earlier, saying that you might need to make reliability, inverted commas, improvements. Was it much of a challenge during that winter, saying like, because you had like a mission objective, you knew you needed to try to increase gas flow sort of through the engine via hot blowing? Was that much of a challenge? Did you have room to make these reliability adjustments, from one season to the other? was it possible to make any adjustments and improve it from the lessons that you'd learned in 2011?
Yeah, it was. I mean, remember that these engines are built for performance, and as part of that, they have to be durable. When you go to Monza, you end up with, I think, 30, 40 seconds of full throttle time. So the engine can survive that long of absolute full throttle. And I think it's now tends to be the same at Silverstone as well, actually, where there's an extended full throttle time. So when we're talking about a relatively short period of time in each braking zone, you can have the engine producing heat in the exhaust, and it's not too bad because it doesn't heat soak. You generate a bit of heat, but then you've got another straight where it settles down to what's more normal again. So there was an element that we could just turn it on and make it, and it survived. Obviously, we had limits to stay within, and if those limits weren't there in terms of hardware limits, we could have pushed it further. So if the FIA hadn't stopped the main effectiveness by repositioning the exhaust, and development had continued in that area, we'd probably be now sat in a position where the exhaust valves can deal with thousands and thousands of degrees of temperature consistently, and the engines would have just developed down whichever path is available. Back then, as I say, we went from cold blowing on 8-cylinder full cut to hot blowing with cylinders fired, and that in itself took a bit of work, because if I take a slight step into the world of crank dynamics now, bear with me, Spanners, I know you love all this, but the natural mechanism for reducing from 8 cylinders down to 4 cylinders at the time was to run not as a V8, not as a V4, but as a straight 4. So when you cut 4 cylinders, the smoothest way to do that and continue with torque delivery to the engine was to fire all of the left-hand cylinders or all of the right-hand cylinders, but not any 2 on each side, which is really good for crank dynamics and for sort of smooth running and good endurance. But then when you think about how the hot blowing works, if you then turn on hot blowing and you're now firing the 4 cylinders on one side of the engine only, then the diffuser is going to be energized on one side and not at all on the other, which would have all sorts of odd effects for the car side. So the first real thing for us to get hold of was, hang on a minute, we now have to deliver high hot flow exhaust on both sides of the engine, which was a change to what we'd done before.
I just have a quick question. I had thought that for hot blowing, the fuel went into the exhaust before it was ignited, but you mentioned firing cylinders. Were you actually creating torque on the crankshaft and igniting fuel in the chamber itself, or was the fuel being ignited only in the exhaust?
The only injectors on the engine were in the inlet tract. So the fuel is coming in through the inlet valve into the cylinder, and then the only spark you've got is in the cylinder. So you are generating positive torque from those cylinders, which is why the torque demand was important, because you don't want to deliver too much. So if you delay the spark as late as you can, then it tends to explode beyond the point where it's making effective power. So obviously that then puts a lot of heat straight into the exhaust pipe, and that high level of heat makes the air very much less dense. So your flow rate increases even more. So it's really sensitive to burning late in the cycle, but fundamentally it still has to burn and explode in the cylinder. And therefore you end up with, in this strange condition, a negative effect of positive torque being produced.
Okay, that's absolutely fascinating. I would love to spend all night talking to you on this, but I'm quite aware that we're running out of time. So one of my final questions to you would be, from an engineer's point of view, and you're sort of working on this, was this a fun thing to be involved in, or was this a royal pain in the backside, where you're like, when your superiors or somebody comes to you and said, right, we need to develop more strategies for this, was it a groan, or was it, good, this is something cool to get my teeth stuck into?
Oh no, this was amazing. I think most engineers we all go to work, we all love to make a difference, and this was a real exciting time as a sort of engine engineer, where you could really bring a lot of performance to the table in a way that's quite new and an innovative way that takes a bit of different thinking. So no, it was really exciting, and there weren't any rules to follow in many ways. There wasn't a well-trodden path. It was a case of, we think there's something to go after. We can hear that some of the other engines sound a bit weird. Go and find out why and make the best engine you can. So it was great from my personal perspective, and I think all of the engine guys were really enjoying that. It's a shame to some extent that it got clamped down on, but obviously that always happens, and there's always something else to go and hunt after separately. So as we all know, you'll spend everything you've got as an F1 team and a bit more probably. So we'll just keep looking, spending just as much time and effort and hard work on whatever comes next.
Well, thank you very much for coming and talking to us about this. I hope you will consider coming back maybe and answering some more engine-related questions in the future.
Yeah, of course. It's been great fun, and keep putting out all the great content that you do, because it's exciting and it's nice to listen to from the outside. As I would hesitate to say an expert, but certainly I've got a little bit more inside knowledge. So listening into what you pick up on and what's more general and what's more sort of publicly known is always really interesting.
Great. Is there anything you want to plug before we head off?
Well, I guess, as you can see from my background here, and you mentioned earlier on, I race a Caterham myself. So in fact, that's how I got into the podcast, because I used to be a race instructor with a certain Mr. Philpott, who you may know. And I was following him, and he started talking about the podcast. So that's how I got involved. And I do a lot of that whenever I can. Fitting it in around work isn't always easy, but it's really good fun. And I've got plenty of social media channels. So by all means, have a look on Instagram or YouTube. We've even got a Discord channel. So James Wingfield Racing on any of those. It'd be great to have people come and have a look at the content I've got out there, and even a few kind of engineering-based setup help videos on YouTube. So have a look and let me know what you think.
Well, thank you very much. Kyle, where can we find you?
I lurk on the Twitters every now and then. So it's Kyle Power F1 on Twitters. And I have a very underwhelming YouTube channel, which isn't as good as James is, unfortunately. So there are a few iRacing things and something from my previous sort of karting experiences, but mainly I hang around on Twitter. So if you want to see some angry ramblings at times, go and check me out on there.
Great. And I'm always at Matt PT55 on whatever social media you care to look for me for. Thanks again. Talk to you soon.
Well, you learn something new every day. I always thought it was just a matter of the harder you pressed the pedal, the faster you went. But apparently not. Thanks, Trumpets, and thanks, Kyle, and thanks, James. It's amazing to be able to talk to someone who was there and hands-on during that whole development process. His insider knowledge and insights are really priceless. That's about it for this week. Next week you'll be in the company of another of Missed Apex's favourite uncles. That's right, Uncle Joe Saywood is returning to the shed with spanners to discuss and dissect the F1 season just past, the one that's about to engulf us, and all the rumours, gossip and speculation that make F1 so much fun. Until then, as Spanners always says, work hard, be kind and have fun. This was Missed Apex Podcast.